Hi everybody, today we are going to study the examples related to domain and range of the functions. In that, our first example is f of x is equal to 1 upon 3x minus 6. Okay, now here to find first the domain of the function, it is all about a real number. Here our domain and codomain should be present in a real number only. Okay, we are getting the examples related to real numbers. Okay, that is, here we have to check whether the given function should be real for any value of x. Okay, now here function is 1 upon 3x minus 6. So when the denominator will be 0, it will be not defined. We know that 1 upon 0 is infinity. So our denominator should be not equal to 0. Therefore, for 3x minus 6 not equal to 0. So that we can find the value of x. Here, it can be written as 3x minus 6 not equal to 0, which means 3x is not equal to 6. Okay, which means that x is not equal to 2. That is, for x is equal to 2, our denominator will be 0. So that we have to take x not equal to 2 for the function f of x is equal to 0. So in a domain set, 2 is absent. Okay, or we have to delete 2 from our domain set. So for any remaining value of x from a real number, it will be not equal to 0. So our domain set will be domain of f will be belongs to R minus singleton 2. Okay, we have to delete this 2 from a real number, which will be our domain set, or we can also say that it is this 2 is not. So here all values from 2. Okay, deleting this point only, all other values on a real line is our domain set, or we can write it also, that is, it can be written as domain of f is equal to r minus infinity to t 2, it is open, union 2 to infinity. Okay, this is our domain set. It also written as in this type also. Okay, now we have to find the range of the function. We have to find the range of the function. Now here function is y is equal to f of x is equal to 1 upon 3x minus 6. So here we can consider it as y is equal to f of x. So it can be written as y is equal to 1 upon 3x minus 6. Okay, so it can be written as, here denominator can be multiplied to the left side. So it will be y into bracket 3x minus 6 is equal to 1. Okay, we have to write an expression in the form of x now. Okay, so it can be written as y into 3x minus 6. So multiply y into bracket 3xy minus 6y is equal to 1. Okay, so get this 6y term on right side. So it will be positive. 3xy is equal to 1 plus 6y. Okay, now we have to find the value of x. So x can be written as x is equal to 1 plus 6y divided by 3 into y. Okay, so in this example, x can be written in the form of 1 plus 6y upon 3y. Okay, where x is our real number. Okay, so our right side should be also a real number. Okay, so it will be real only if its denominator will be not equal to 0. Okay, here it will be real when denominator not equal to 0, that is 3y not equal to 0, that is y not equal to 0. So our range will be range of y will belongs to r minus singleton 0. Okay, if y is equal to 0, then it will be infinity and it will not be defined. Okay, so you have a range of y as r minus singleton 0, or it can be also written as minus infinity to 0 union 0 to infinity. Okay, which is our range of the given function. Okay. Now our next example is f of x is equal to square root of x minus 3. As we know that square root of negative is always complex, okay, which is our complex number. Okay, here we required only a real number. So here x minus 3 or into bracket root term will be always greater than equal to 0. So here x minus 3 should be greater than equal to 0 so that it will be a real number. So here we can write it as x minus 3 greater than equal to 0, which means x greater than equal to 3, which is our domain. Okay. So our domain set will be domain of f belongs to here x greater than 3. If we represent it on a line, real line, or it also known as number line, greater than or equal to 3, which means your set will contain values greater than 3. Okay, this is denoted by this type. So domain of f can be written as close 3 because 3 is contained in it, because 3 minus 3 is 0 and root of 0 is neutral, so it will be real number. If it is greater than less than 3, it will be 2 minus 3 is minus 1, which is complex number, or if you consider 0 minus 3 is negative, so it is complex number, so it will not be present in a domain. Okay, so our domain set is 3 comma infinity. Okay, should be open at infinity, which is our domain of f. Now to find a range, now here we require to find a range. Now here our domain is 3 to infinity, so here value of x will be lie between 3 less than equal to x less than infinity. Okay, here it is a closed bracket, so it will be written as 3 less than equal to x less than infinity. Okay, now here our function is square root of x minus 3, so subtracting throughout by 3 we get 3 minus 3 less than equal to x minus 3 less than infinity minus 3. Okay, so it will be 3 minus 3 is 0 less than equal to x minus 3 less than infinity minus 3 is infinity. Okay, when we subtract any number from infinity, it is always infinity only. Now here it can be taking square root. We are here finding a function f of x. Okay, so here it can be taking square root. We get 0 square root is 0, sign will be remain as it is, square root of x minus 3, and square root of infinity is again infinity. Okay, which is a function 0 less than equal to f of x less than infinity. That is value of the function. Value of the function will lie between 0 and infinity. That is we have to find the range. Okay, so range will be, range of f will be belongs to, here it is less than equal to, so it will be close 0 and open infinity. Okay, which is our range of the given function. Okay, now consider function f of x is equal to 1 upon square root of x minus 9. Now it is in denominator. Okay, so here we have to find a value of x such that it will be a positive. Okay, root of, because if root is negative it will be a complex number, and we have to find a value should not be equal to 0. If it is equal to 0, our term will be 1 upon 0 and it will be infinity. Okay, so here we required two conditions, that are it should be a positive, square root will be positive and not equal to 0. Okay, we have to find these two conditions. Okay, so it will be x minus 9, it is considered as greater than 0. Okay, which will be positive. Okay, here we are considering x minus 9, which is in root term, it should be greater than 0. If you consider greater than or equal to 0, it will be 0 and 1 upon 0 will be infinity. So here we are considering x minus 9 greater than 0, which means x should be greater than 9. Okay, which means x should be greater than 9. So that here domain set will be, domain of f can be directly written as, okay, x greater than 9, which means open bracket 9, here it is greater than 9, so it is 9 comma infinity, or on real number line, you can consider here 9 and open. So here 9 is not including in this set. So this is our set of domain. Okay. So here 9 to infinity. Now to find range, we can solve it as above example only. Range of f. Here our condition is 9 less than x less than infinity. Value of 9 will be in between 9 and infinity, because 9 less than x less than infinity. Now we have to find a function. So we take a calculation such that we subtract 9 from throughout this equation. We get 9 minus 9 less than x minus 9 less than infinity, so that we get square root term. Okay. So 9 minus 9 is 0, less than x minus 9 less than infinity. Now we here take a reciprocal. So we can write here 1 upon 0. Okay, 1 upon x minus 9 and 1 upon infinity. Okay. Now you know that if we are taking reciprocal, our less than sign is taken as a greater than. Okay, here it will be less than, it should be a greater than and greater than. For example, if you consider 2 is less than 5. Okay, 2 is less than 5. If we take a reciprocal 1/2 and 1/5, in that term 1/2 is greater than 1/5, because we know that 1 upon 2 is 0.5 and 1 upon 5 is 0.2. Okay, and 0.5 is greater than 0.2. So when you are taking a reciprocal of any terms, if there is a less than sign, it will become a greater than sign. If it is greater than, it will become less than. So here it will be 1 upon 0 greater than 1 upon x minus 9 greater than 1 upon infinity. But 1 upon 0 is infinity, greater than 1 upon x minus 9 is as it is, and 1 upon infinity is 0. Okay, which means 0, here we write it as 0 less than 1 upon x minus 9 less than infinity. Okay, now our function is 1 upon square root of x minus 9. So we have to take a root. So 0 root is 0 less than 1 root is 1. So it is not necessary to take numerator square root, and denominator square root is x minus 9 and less than infinity. Okay, which can be written as 0 less than f of x less than infinity. That is, our range of a function is 0 to infinity, which is not 0, it is near 0 up to infinity. So range of f belongs to open interval 0 comma infinity. Okay, here it is less than condition, so it will be open bracket on both sides. Okay, now a function is given f of x is equal to square root of 9 minus x square. Now again here we have to check. Now it is a numerator only, it is not in a fraction type. So in this example we have to check only it is whether negative for which value of it is negative and for which value it is negative. Okay, so here we required 9 minus x square should be positive. If it is negative, it will be a complex number. Okay, so we have to find 9 minus x square such that it will be greater than or equal to 0. Okay, here if it is 0, no problem, because 0 is a real number. It is not in a fraction form. Okay, if it is in fraction form, we have to delete this condition also. We have only 9 minus x square greater than 0. Okay, so here 9 minus x square greater than 0, which means if we consider minus x square plus 9 greater than or equal to 0. Now we required x as a positive, so we can write it throughout multiplied by minus 1 on both sides, multiply by minus 1. So here it can be written as x square minus 9, here it is 0. Here now when we are multiplying negative signs on both sides, it can be written as this equation minus x square plus 9 will become, here it is greater than or equal to, it will become less than or equal to 0. Okay, or you can also solve it like this, or you can shift minus x square 9 minus x square on right side, so it will be become 0 greater than or equal to x square minus 9, which means that is x square minus 9 less than equal to 0. Okay, these are two process which is easy, you can take from here. Okay, now we have to find the value of x which satisfies this condition, that is x square minus less than equal to 0. That is here x square minus 9 equal to 0, which means that x minus 3 into x plus 3 less than equal to 0. That is, we have two values, x is equal to 3 and x is equal to minus 3. Okay, now we have to find the domain for values of x and x is equal to minus 3. So if we draw a real line and plot this point minus 3 and 3, okay, these are points on a real line. Okay, now in this we have to find a domain set. Now to find a domain set for values of x, we have to check these intervals. There are three intervals, one from minus infinity to minus 3, second interval minus 3 to 3, and next third interval is 3 to infinity. Okay, we have to check the values in these three intervals. We have to check the values intervals such that it should be less than equal to 0. Values of x should be less than equal to 0, which satisfies these conditions, x square minus 9 less than equal to 0. Okay, now for that, if you consider value of x greater than 3, which should be present in this right side of 3, so if you consider x is equal to 4, okay, if you write x is equal to 4, here this equation, if you consider equation star, therefore equation star, we have to check only sign, it will be positive, negative. Okay, so here x is equal to 4, it will be 4 minus 3 into 4 plus 3, okay, which is positive. 4 minus 3 is 1 and 4 plus 3 is 7, which is greater than 0. Okay, that means the when we take x as greater than 3, it will be here positive. Okay, in this domain. For 3 it is 0. For 3 it is 0. And for greater than 3 it will be 3 to infinity, it is positive. Okay, next in between minus 3 and 3, if we take x is equal to 1 in equation star, we can write 1 minus 3 is 1 minus 3 into 1 plus 3 is equal to, which is minus 2, and plus 4, which is minus 8, and which is less than 0. That means in between minus and 3 it will be negative, that is less than 0. It will be, the calculation will be less than or equal to less than 0 only in minus 3 and 3. Okay, similarly for x is equal to greater than value x, we can consider minus 4, equation star will give us as minus 3 into minus 3 plus, minus 4 minus 3 minus 4 plus 3, which is equal to minus 7 into minus 1, which is positive, 7, which is greater than 0. That is, in interval for minus 3's left side, it is again positive. Okay, our function is positive. Now we have to find the domain value such that it will satisfy this condition, x minus 3 into x plus 3 is less than equal to 0. Now if you see this three interval, in this three interval, in interval minus 3 to 3, in interval minus 3 to 3, value is less than or equal to 0, which is negative. Negative means which is less than 0. Okay, and at minus 3 and 3 it is 0. So our interval domain will be, domain of f will be belongs to minus 3 to 3. Okay, this is our domain. Or you can here write it is greater than 0, here it is less than 0, again it is here greater than 0. Okay, so you have to represent it on a real line so that you can observe it and you can clearly define the domain of a function. Okay, now we have to find the range of f. Now to find range of f, here our values domain is minus 3 to 3. Now here function is y is equal to f of x, okay, which is equal to square root of 9 minus x square. Okay, so here y is equal to, that is y is equal to square root of 9 minus x square. That means y square can be written as 9 minus x square. As it is here, it is y square, so y should be greater than or equal to 0. Okay, which is our equation number 1. Consider as equation number 1. As it is square, quadratic equation, so y square is equal to 9 minus x square, which means that it should be, because here it is positive, 9 minus x square is greater than 0, so y should be greater than 0 only. So y square is equal to 9 minus x square, which gives x square is equal to, if we shift this to left and y square to right side, we get y square is equal to x square is equal to 9 minus y square. We have to write an equation in form of x. Now here x is equal to plus minus square root of 9 minus y square. X is equal to plus minus square root of 9 minus y square. Now here 9 minus, here if it is negative, it will be again complex. Square root is negative, then it will be complex. Therefore for value of y greater than, we have to find the value of 9 minus y square should be positive. Okay, that is here 9 minus y square should be greater than or equal to 0. That means 9 minus y square greater than or equal to 0, which means y square minus 9 should be less than or equal to 0. Okay, it is, we have done here, or we can write it as, that is 9, here minus y square get on right, it is greater than sign, 9 minus 9 greater than y square. Or you can write here, we shift this total term to the right side, it is here, it remain only 0, y square will be positive on right side and 9 will be negative, y square minus 9. Okay, that is y square minus 9 less than equal to 0. Okay, y square minus 9 less than equal to 0, which means y gets two values, y is equal to 3 and y is equal to minus 3. Okay, so y here belongs to minus 3 to 3. Okay, now consider it as equation T. But here we have an interval y greater than 0. We have the values of y should be greater than 0. Okay, as the function, in a function here given f of x is equal to 9 minus x square. If we take the values of x, then it will be greater than 0 only, or equal to 0. It is not less than 0. So here interval from equation 1 and 2, from 1 and 2, here interval minus 3 to 3. Okay, and we have second condition 0, y greater than 0. So common in between 2, y greater than equal to 0 and y belongs to minus 3 to 3. So common from this both is only 0 to 3. Okay, so here range of f will belongs to 0 to 3. Okay, which is our required solution. So range will be 0 to 3. Now consider the next example, f of x is equal to square root of x square plus 3x minus 28. Okay, now here we have required x square plus 3x minus 28 should be greater than or equal to 0. Okay, so that it will be a real. If it is less than 0, it will be a complex number. So here we have a condition x square plus 3x minus 28 should be greater than or equal to 0. Okay, now if we solve this an equation, here factor of 28 are 4 7s are 28 and it is negative minus 28, so larger number with negative sign, it is 4 and minus 7. Okay, and 4 minus 7, sorry, here it is required here plus 3, so it will be minus 4 plus 7. Okay, because minus 4 plus 7 is 3, our middle term is 3. Now it can be written as x minus 4 into x plus 7 greater than or equal to 0. So that we get two values, x is equal to 4 and x is equal to minus 7. Okay, so again here we draw a real line. From real line we can find the values where it should be our domain set. Okay, now again here it is from minus infinity to minus 7, it is our one set. Minus 7 to 4 is our again second interval, and 4 to infinity it is our third interval. Now from equations, if we define it as equation star, for value greater than 4 it will be 5. If we consider 5 minus 4 is positive term and 5 plus 7 is positive, so it will be greater than 0 or it is positive. Okay, or you can write here for x is equal to 5, equation star can be written as 5 minus 4 into 5 plus 7, which is 5 minus 4 is 1 and 5 plus 7 is 12, which is 12, which is greater than 0. So in this interval from 4 to infinity, we are not considering 4 in that interval, it is open. Okay, in this interval our value of f of x is greater than 0. Okay, now in between those these two, minus 7 to 4, so we consider any one value. If we consider easy value, x is equal to, if you consider x is equal to 0, it will be equation star will be 0 minus 4 into 0 plus 7, which is minus 4 into 7 minus 28 is less than 0. So that we can say that in interval minus 7 to 4 we have a functional value negative, which is less than 0. Okay, which is less than 0. Now for minus 7 we take a value from interval minus infinity to minus 7 as x is equal to minus 8. Equation star gives minus 8 minus 4 into minus 8 plus 7, which means it is minus 8 minus 4 minus 12 into minus 1, which is plus 12, which is greater than 0. So again in this interval value of function is greater than 0. Okay, now equation, if we see the equation star here, product of these two terms x minus 4 into x minus 7 should be greater than or equal to 0. We required x minus 4 into x plus 7 greater than or equal to 0. Okay, so if we see this representation in interval minus infinity to minus 7 it is greater than 0, and in interval 4 to infinity it is greater than 0. So our domain set will be, domain of f belongs to interval minus infinity to minus 7, which is minus infinity comma minus 7. It is close here because 0, if it is 0 here greater than equal to 0, we have no problem. Union, now here it is, we does not take interval minus 7 to 4 because there is value negative, which is less than or less than 0. So we start from interval value 4. At 4 it is 0 and after that it is greater than 0. So our next part will be 4 comma infinity. Okay, which is our domain of f. Okay, now we have to find here a range. Okay, a range of f. When in this type our given equation is of the form square root of x square plus 3x minus 8. Okay, now we have to find its domain. So to find y is equal to f of x, and f of x is our of the form x square plus 3x minus 28. Okay, so here we adjust the terms such that we can write it as square root of, here it can be written as y x square plus 3x plus 3 upon 2 bracket square minus 3 upon 2 bracket square minus 28. Okay, what we have done here, we are doing here adjustments such that it will be bracket square. It can be written as bracket term square. So here it can be written as, if you know that an quadratic equation ax square plus bx plus c. So if we have to write in the form a plus b bracket square, we write b upon 2 or its half, we add and subtract. Okay, because we know that our general form is a plus b bracket square can be written as a square plus twice ab plus b square. Okay, which means that our coefficient or middle term is twice the times a into b. Okay, now here we have to adjust it, so we required here coefficient of x should be half. Coefficient of x should be half. So we here add 3 by 2 square minus 3 by 2 square. Okay, so that we can write in the form as, here it will be expansion of x plus 3 by 2 bracket square. Okay, if you do expansion of this square, we get x square plus 3x plus 3 by 2 bracket square, and here minus 9 upon 4 minus 28 as it is, y is equal to. Okay, so here y square can be written as x plus 3 by 2, and this calculation minus 9 upon 4 minus 28 can be written as minus 9 minus 28 into 4. 28 into 4 is equal to 112 upon 4. Okay, which gives us as minus 121 divided by 4. Okay, so here we write minus 121 divided by 4. Okay, x plus 3 bracket square. Now we have to find the values of x here. So if we consider the only right side, x plus 3 by 2 bracket square minus 1214 equal to as a 0. So we can get the values of x such that here as x plus 3 by 2 bracket square is equal to 121 divided by 4. Okay, now here if take square root, we get x plus 3 by 2 is equal to 121. It is plus minus 11 upon 2. Okay, which means that x plus 3 by 2, which means that x plus 3 by 2 is equal to 11 by 2, or x plus 3 by 2 is equal to minus 11 by 2, which implies that x is equal to 11 by 2 minus 3 by 2, and which implies that x is equal to minus 11 by 2 minus 3 by 2, which gives, if we solve, denominator is same, 11 minus 3 is 8, 8 divided by 2 is 4, and minus 11 minus 3, which is again minus 7. Write it as, now here if we consider as the values 4 and minus 7, if you are putting the values in given equation f of x is equal to square root of x square plus 3x minus 28, the value will be 4 square minus 3, as we have getting the roots. For x is equal to 4, it is 0. For x is equal to minus 7, it is 0. So our range will be range of f belongs to now it is starting from 0, because at x is equal to 4 it is 0, and for x is equal to minus 7 also it is 0. Now we have to check whether it is goes to or positive or it goes to minus infinity. Now for this example, if you are considering x values, or we are considering this as sets, here values are both 0, minus in interval minus infinity to minus 7 it is greater than 0, and in interval minus 4 to infinity also it is greater than 0. So our interval range will be from 0 to infinity in both. Here it is also at 0 and it is greater than 0, which means that it is going toward positive infinity only. So our range will be from 0 to infinity only. Okay, range of f belongs to 0 to infinity. Okay, or you can directly, it is here it is not necessary to this calculations also, you can write from this also. Here you can see that values of x are at 4 and minus 7 are which is domain set is minus infinity to minus 7. Here it is greater than 0. Okay, and in this interval also it is greater than 0, 4 to infinity and minus infinity to minus 7, and its least value, which means at minus 7 and minus 4 it is equal to 0. Okay, so you can here directly also write it as range of f as belongs to, it start from 0 and it ends at infinity. Okay, so by this process also you can solve, or you can directly write from its domain set also, range of f belongs to its closed interval 0 to open interval infinity. Okay, so these are the examples related to domain and range of the function for a real sets only, when f is from real number to real numbers only. Okay, so today we stop here. We in next lecture also we will study some different types of examples related to domain and range of the function only. Okay, this is an important topic related to you in 11th also and for 12th also, and in your future study it is very most important unit, function. Okay, so for today we stop here. Thank you.